NASA's plan has identified a number of foundational capabilities, right? You've seen it in the document, from lunar rovers to foundational surface habitats, and also a start at ISRU and power equipment. And the importance of science is described in this plan. These items are significant, but they don't represent a settlement. They are the necessary building blocks of one, though. So thinking about an economically viable lunar settlement, what are the technology gaps and what can be done to close them? You know, will the Lunar Surface Innovation Consortium that NASA has set up to bring together industry, government, and academia to tackle some of these hard problems, will that be enough to get us where we need to be? What are the economic conditions necessary to achieve our goals, and how do we get there? So these are some of the questions we're going to discuss and try to tackle with this workshop, with the goal of identifying actionable recommendations for the near term and the midterm. So keep that in mind when you get into your breakout groups. So with that, let's get started. I want to ask the panelists to quickly introduce themselves, and then we'll start with questions and answers. We're going to start in alphabetical order by first name, so remember that theme. And I'm going to ask Ahsan Chowdhury to introduce himself.
Good morning and good evening all. This is Ahsan Chowdhury. I'm an Associate Vice President and I lead University of Texas El Paso's Aerospace Center. Thank you.
Thank you. And Ariel Etblau.
Hello, everyone. I'm Ariel. I'm the founder and lead of the MIT Media Lab Space Exploration Initiative and working with David Newman at MIT on our activities to send research back to the surface of the moon, presumably with Blue Origin and other partners.
George Sowers.
Hi, everyone. I'm George Sowers. I'm a professor at the Colorado School of Mines supporting the world's first and only graduate program in space resources. And before that, I had 30 years in aerospace with Martin Marietta, Lockheed Martin, and United Launch Alliance, where I retired a few years ago as the chief scientist.
And Lindy Elkins-Tanton.
Hi, everybody. I'm a planetary scientist, geology and geophysicist at Arizona State University. I'm the principal investigator of the NASA Psyche mission and the managing director of ASU's Interplanetary Initiative.
So thanks, everyone. And so we're going to break this conversation into two parts today. I'm going to start with technologies and gaps, and then we'll move into a discussion of the economic conditions that are necessary. So I want to ask each of you to share your thoughts on technology gaps and the role that you think NASA or other space agencies should play in closing these gaps. And any insights you have into how to motivate this government spending would also be helpful. So George, why don't you go first?
Yeah, thanks, Kathy. So I'll talk about capability gaps because there's always a lot of technological solutions out there to solve any particular engineering problem. If we want a settlement to be economically viable, we got to make sure we can keep the cost down. And so I think some of the most important technology gaps that we have in that regard is the ability to utilize lunar materials to meet the needs of the settlement. That avoids the very high cost of bringing things from Earth. In that regard, one of the first pieces of infrastructure a settlement is going to need is a landing pad. This avoids the creation of dust from repeated landings. Ideally, we would want to make a landing pad out of lunar materials, and material that we have in abundance there is lunar regolith. So a capability gap is creating viable and building materials from lunar regolith, building and construction materials. Another use of lunar resources that will be important very early on is water from the lunar poles. And those of you that are familiar with my talks and work over the last several years, that this is kind of my topic of research, but water's essential for life support and agriculture. It makes great radiation shielding, and then of course you can separate it into oxygen and hydrogen for rocket propellants. That's important, especially early, because it's going to lower the cost of everything. The use of lunar propellant lowers the cost to get to the moon from Earth by a factor of 3. which is critical for economic sustainability. And then even more importantly, it lowers the cost to get back from the moon by almost 2 orders of magnitude, a factor of roughly 70. And then thirdly, it's going to be important to be able to manufacture hardware on the moon from lunar materials, metals. The moon is rich in metals and other elements that are important for industrial use and raw materials. Initially, that'll be for tools and spare parts. But eventually, a sustainable settlement is going to want to be able to manufacture things like solar panels and other more complex products. So that's 3 technology gaps right off the bat. Lunar regoliths for building materials, water for life support and propellant, and then metals and other materials for manufacturing hardware.
Okay, thanks, George. Ariel, how about you?
Thanks, Kathy. So George hits on all of the critical highlights. We agree for those top 3. What I might add to that would be also a focus on interoperability for the technologies that we would deploy, so that when we're able to be thinking about precision landing and landing pads, right, the core focus of CLIPS for the first stage in that NASA Sustained Development Plan, all the way through to communication infrastructure and architectures. That's one of the areas that MIT is exploring through a couple different projects that are being planned for the early stages, 2023, 2024 for lunar missions, is thinking about the deployment of nodes, so small units that could double as an infrastructure for sensing on the surface and give us critical information about where to put landing pads, do a little bit of seismic understanding of the lunar surface, things like that. But then also using these sensor nodes to double as communication, wireless networks that could establish a system that allows lots of different stakeholders and actors on the lunar surface to be able to communicate and coordinate their plans. We could also see this arising with habitats if we do this correctly. So we're interested from an architectural standpoint in thinking about deployable habitats, deployable flexible structures, and also potentially answering that modular mobile habitat call that's in the sustained plan for lunar development through, again, interfaces that ideally would be interoperable and is planned with other stakeholders, so that as we're expanding a settlement, we're not building silos, we're from the very beginning building a network. A city, like an urban planner would design a city now, we had the opportunity to think about the ways to do those tie-ins early. And then the last thing that I'll add, which is coming out of some interesting research from Martin Elvis at Harvard, is well known that a lot of the concentration of lunar resources, of which we are very interested in, lunar volatiles, ice and other things, they seem to be concentrated in particular regions on the surface of the moon. And so while this might be a longer term consideration, it's of interest to us to begin to think about supply chain engineering, mobility and logistics, so that we're able to potentially support activity distributed more equitably around the surface of the moon, but still being able to access the critical areas. And we think if we don't, then we're at a risk for potential future conflict. And so we'd love to be able to think early, even though it'd be a dream to have even one, active settlement here on the surface of the moon. Eventually, we may have a crowding or a competition issue. So how can we think about the supply chain infrastructure and some logistics to be able to distribute particularly concentrated resources to other areas of the surface?
Well, those are some great points. I mean, you bring up not only what, but how, and the importance of understanding how, like interoperability and supply chains, and what might derive from that assessment that are worth investment in coordination today. So those are great points. Okay, next, Asan.
Again, thank you. Definitely, I agree with George and Ariel, but a sustainable lunar settlement will require basically operating a large industrial plant on lunar surface. And if that is in a South Pole or polar region, obviously the Artemis base will be in the South Polar region, we can experience a temperature anywhere between 50K to 200 Kelvin. That's really cold. So this plant has to, operate in autonomously or semi-autonomously. So our maximum experience in operating lunar surface is not more than 16 days. And we did operate on Mars surface with smaller robotic equipment, but operating a very large industrial plant is something completely unknown. With that kind of temperature extreme, lunar dust, as well as the radiation. So the piecewise many technology exists to operate that, but we are unsure that, I'm giving an example of electronics. If you have to create all warm box for every electronics you have on the lunar surface, that is going to be a huge challenge for us. So I think there are many components needs to be reevaluated, that how we can operate a big industrial plant on lunar surface for long duration operation. We need to bring partners beyond NASA, traditional aerospace defense industry, as well as academia. We need to bring people who run offshore drilling operation, who run Arctic operation or do mining operation art, because they have the ability or some understanding how to really operate in extreme environment. So obviously, there are a lot of component level technology development is still needed. To me, a large system operating on lunar surface is something completely unknown to us. So we have to create an analog on Earth's surface. It's not possible to create that kind of thermal radiation environment, but at least we can do accelerated mission testing. Something the gas turbine and other industry continuously use to figure that out. So that is a major point, that how we can operate a heavy machinery on lunar surface without that breaking down in every 30 minutes, or don't operate after 2 months. Okay, it's not known, and I don't see much research on that area, and that needs to be beefed up. So something I believe is most important, that obviously component level, because most materials gonna get brittle or phase change in that kind of thermal cycling environment. So everything needs to be rethought and needs to create a system level understanding operating a large industrial plant on lunar surface. So that, I think, the most immediate technology gap we need to address. Second thing is kind of a little bit different. Lunar settlement, lunar technology development needs to include everyone. Our aerospace and defense workforce has a stubborn issue of diversity. So we must need to address that our workforce represent all race, ethnicity, and gender. So I believe with technology development, not having a diverse workforce, because diversity is going to power that innovation. So I think that's not a separable from our technology development need. Creating a Artemis generation of a diverse workforce is as critical as developing all the technology. Thank you.
Here, and it's going to take all of us
Here,
to
here.
prioritize that. So very good. Lindy, what's your perspective?
These are such great comments we've been hearing. To connect them to the again back and maybe even knit them even more firmly with the goal of our workshop today, the criticality of determining both the real and hidden technology gaps, and getting all three sectors, government, universities, private sector, together to solve this. It's very important to remember this is not something that NASA or any space agency can do on their own. In fact, it's not possible for them to fully convene the private sector when they're also creating proposal calls. George's points about lunar geology and the composition of icy deposits and the economic geology of those sources is also something very close to my heart and something he and I have talked about a lot. And an example of perhaps a hidden technology gap is the fact that if a lot of our volatiles came from, for example, meteorite impacts, this kind of thing, then they might be as much as half organics and not really just made of CO2 and H2O. And so really that's an example of how we need to get the geologists, the chemists together with the universities and the researchers to try to solve these things, because these are insights that people wouldn't find on their own if they're just coming from the tech side. And Ariel's points about the interoperability, you can say that word better than I can. I have to practice now. I think that's so incredibly important. This is something that, to give a shout out to Open Lunar, something that we're working together, Ariel and I and others with Open Lunar, to work on shared technologies and standards. And that connects directly with what Asan is talking about, the critical importance of joining together and not making this return to the moon a proxy for war. This is not our time to do posturing with China, but instead to come together as humanity to be our better selves. And sharing technology and standards is a really major way to do that. And it goes right along with moving into the unknown when making a big lunar settlement, picking partners beyond the usual, as Asan said, organizationally and individually. And that means creating a culture of inclusion and diversity, which is not something that aerospace has always been great at, but I think we are improving at a phenomenal rate, and we can show how it's done. And so to bring together these sectors and the people that we need, the government, university, private sector, the NASA's Lunar Surface Innovation Consortium is fantastic, but it's not enough. I need to shout out that we're going to have a fall meeting sponsored by ASU we and George at Colorado School of Mines are the university leads for LSIC, and it's a great way to bring the sectors together, but there has to be more, and it's up to all of us to come together, creating tech sprints and early prototypes and processes that can be used, and looking into the lunar roadmaps and finding where those gaps are. I think some of the comments coming through chat are great examples of how we can crowdsource this kind of information and put it together into the white paper that we're envisioning for today.
Yeah, you brought up the Lunar Surface Innovation Consortium. Is that a good place to work on interoperability standards? They've got
I think it absolutely is.
communities, many different.
Oh, I'm sorry, I didn't mean to interrupt. Go ahead.
No, go ahead. I think you understood.
I think absolutely. I think that it is one of our major convenings right now that brings together multiple sectors. It's not the only one, but I think that everyone going there to work on exactly these issues and pushing these things that we've suddenly brought up right at the beginning of this webinar, the issues of diversity, the issues of picking beyond the usual suspects. I heard this yesterday from an Assistant Secretary of the Air Force. We need the kind of solutions that are not the same old from the same big partners. We need the unusual things that are coming from individual thinkers. So bring them to LSIC, but bring them to the other forums too, and let's make our voices heard.
Great. And I'm monitoring the comments and questions. I've got a question, Ariel, I'm going to direct this one to you. AI, right? Everybody talks about AI, and I've heard the need for establishing maybe standards associated with how we apply AI in exploration contexts. What are your thoughts on AI technology, and how will that help us get where we want to be in let's say developing an affordable, an affordable approach to solving all these problems and getting where we want to be?
Great question. AI as a monolith is an interesting topic to chunk into. When we think about machine learning and the application of artificial intelligence in the way in that it's used for autonomy, or the way in that it's used for detection of early stage patterns for decay or repairs and things like that, those type of technologies will be very readily used for Gateway. So we already see this part and planning within NASA's plan to let Gateway be a primarily autonomously managed space station, partly because we're expecting seasonal activity for the crews. It won't be continuously inhabited. And to be able to support that, you'll need to be able to have systems that are able to run more autonomously. So there's a measure of machine learning, I would say, not quite AI, but machine learning in being able to tackle that problem. When we think about issues on the lunar surface, AI and machine learning are currently most effective when you have large data sets. There's quite a lot of data that we need to gather first before we can train models to be able to make effective decisions with AI and machine learning tools for the surface. But I absolutely do think that these will be tools that are in the way that they are now. Every advanced technology sector that you look at, these will be tools that are integrated into surface.
Okay. Thanks a lot. So now to the panelists, we're going to shift our thoughts to economic conditions, right? Let's talk about your thoughts on the most likely economic conditions that will enable this, and what can we do to stimulate them? Ariel, why don't you go first?
Thanks, Kathy. So in terms of economic conditions, there's a long-term, well-known to this community concern about capricious political whims or the infeasibility of deploying cost-sink behemoths. And so I think that the way that NASA has scoped the plan so far, the components that are in the Sustained Development Plan, shows a path towards incremental, incredibly ambitious work towards the lunar surface, which I think helps at a base level. What I'll say in terms of the other aspects of a successful economy is it's got to be predicated on an information flow and access to good information about the state of play of actors, the different opportunities for investment, where will you get a return on investment, where will you be able to close the business case. And to do this, we are working with Open Lunar, who Lindy had mentioned at the beginning of the phone call, on what we're calling a lunar open architecture. And Mehek Sarong from my team leads this work at MIT in collaboration with Open Lunar, trying to first level take static PDFs that we've relied on for decades, that the minute that they're published are outdated, and begin to make these PDFs into dynamic tools, living on a website with best-in-class web tools, scraping USPTO and SEC filings to be able to have dynamically updating information in this tool, and then add a layer of data visualization that allows stakeholders, whether they're NASA reps drafting RFPs, or Lindy planning ASU's activities interplanetary, or Erica Ragnar, who I see on the call, thinking about blue strategy for the moon, helping these stakeholders see overlaps where too many actors are involved and it's an economically crowded area. Maybe everybody's thinking about water extraction. And then also see opportunities for areas that are not overly explored, but that are milestones to future development. And if somebody doesn't tackle them, we'll be held back. And so the hope with this tool is to empower information exchange and potentially to make collaboration more possible on the lunar surface, and at least to allow a more efficient distribution of the global resources that we do have that are limited towards a successful, sustainable settlement on the lunar surface.
Great, thank you. Asan? And if I could ask the panelists to be as concise as you can with your answers, just in the interest of time, I would be grateful. So Asan, over to you.
Thank you, Kathy. I'm going to take this a little bit differently. First, obviously, any sustainable lunar economy will require a international broad-based participation. Only one country really cannot create an economy on lunar surface. And United States has demonstrated building ISS that a larger scale international partnership can deliver in amazing things. But things are changing, and geopolitical strategies are continuously evolving. And I believe that first pool of lunar economy will come from our geostrategic advantage. Certainly, United States does not want to own moon, but we don't want anybody else to own it either. So a strategic presence in lunar is part of our defense, should be part of, and I think it is part of our defense space strategy. And defense will play a larger role as a customer to create initial lunar economy. And I'm not promoting that we militarize moon, but again, this is some strategy, defense space strategy needs to be there, because if you put a transponder on a lunar surface, it'll be difficult to jam. So it is a very, very critical strategic position United States has to have strategic advantage on moon. Having said that, any lunar economy will require that it will be connected to the taxpayers' money. In the beginning, 10 to 20 years, we'll have to have a lot of investment. So science play a big role on this, but taxpayer has to really understand that this exploration, this billions of dollars going to lunar surface, has a tangible benefit to them. So it must connect to the taxpayers' initiative. So either this is a lunar propellant production or ISRU, all those stuff. But I think that initial economy will be not only based on science, but it will be also part of our defense strategy.
That's a really key point I want to emphasize, right, for the audience. I think we can all agree that the investments to get this started are going to have to come from governments, and so that's why we ask about how you think the technologies and the capabilities that are needed tie to government needs, to government requirements, because they're going to be the first major investors. And the AAAA has a space colonization technical committee that's given this question a lot of thought. And the way they look at it is in part is, in order to get the settlements that we look for on the moon, we need to consider, how do people live and work on the moon, and NASA's all over those technologies, but also how do they play? So live, work, and play. And so if you think about governments having the first, being the first major investors, and then maybe, super rich people being the next set of big money to come in, and the private sector with their ability to close business cases and make money will put money in. We need to answer that play question too. So technologies and capabilities to help develop the opportunity for people who do go to the moon to enjoy their time off there. So I think that's worth people thinking about it. And Asan, you touched on it very, very well. But let me ask Lindy if she wants to share her thoughts on the topic.
Yeah, I'm pretty obsessed with the space business case, and there really is very little in the way of a business case that closes outside of Earth orbit. And so the big question is, once we do have some idea, and there are lots of ideas of resources and things, materials and products and services, but which ones close when the anchor tenant, that is NASA or ESA, is not a part of the picture anymore? And right now, none of them do. And so I think a very strong starting point is to comb the peer-reviewed technology literature for early TRL. There's so much in there that's thought to be a technology filling gap that's just TRL 0, 1, 2, 3 that companies can pick up and advance that will have an Earth sales strategy and a space sales strategy. And to me, that's the starting point for really getting this economy off the ground.
Thank you. And the last word on this to you, George.
Great, thanks, Kathy. So a word I haven't heard yet is profit. And we're talking about economic sustainability. To me, that means a model of largely private sector actors acting in accordance with the principles of the free market that brings innovation in, it brings competition, and ultimately you get increased capabilities at lower cost. In that kind of a model, the role of the government is primarily to set the rules of engagement and also, to echo Hassan's point, provide security. But if you're going to make a profit, then, rule number one is your revenues have to exceed your costs. And so if you're looking at the revenue side of things, you need customers. I think early on, the government will be a very important customer and maybe the inaugural customer for certain things. There are business cases that close, and I've looked at the propellant business case an awful lot. And that actually can close with a combination of government and commercial customers. And once you get that one done, then you can lower the cost side of the equation as well by reducing the cost to get to the moon and to get back. So hopefully that lowers barriers of entry and you can start having other business models that close as well. But it's very important to think about who those initial customers are going to be. And it's super important that the government thinks of themselves as a customer and not a competitor. A customer for things like commodities, like propellant and water, a customer for utilities like power and communications, and ultimately a customer for manufactured goods, including satellites that could be exported into cislunar space. So I think economic sustainability really is going to hinge on sort of a private sector, free market type principles.
Very good. I've got one question from the crowd. I'm going to direct it to Lindy, and that has to do. And the question is, could a robot be the first citizen in space? But I want you to talk about, if we're going to build the business cases and the excitement around, expanding our economic sphere to the moon. Is there a phase where, there are robots that serve as avatars, or I don't know, is there any advantage to, creating an ecosystem with robots there that people can follow and operate and control that prepare the way?
Yeah, I actually think that would be great. And of course, robot is such a broad term. Of course, we're going to have so many robots on the moon. They're just not all going to look like people or beings, and they're not all going to be avatars for people. But there are two advantages to going in a direction a bit like that. One is that it's much easier for us to send robots in the beginning, and of course we will be doing that, no doubt. And another one is getting the sentiment of society behind us. I'm 100% with George. I mean, when I was talking about business cases closing and starting with an Earth market, of course I'm talking about profit. What else are we talking about? That's the thing that's going to keep us going. But the other thing that's going to keep us going is the support and enthusiasm of humanity. And that is at its basis the purpose of going into space, to inspire us all to be better and bolder and do more here on Earth. And so that kind of vision is a great one. It's like virtual tourism, so it's available to people at a lower price point.
Yeah, and especially the human missions, at least in the first bunch of years, or there's going to be 1 or 2 flights a year, right? I mean, there's a lot of time that there'll be infrastructure on the moon that we want to engage people with, that we will be able to do with the ability to rely on capabilities already there, whether they're robots and other capabilities. So, okay, well, that wraps it up. I wish we had more time. This is fascinating. And a lot of great ideas have come from this to seed the discussions in the breakout groups. So I just want to summarize briefly and say that what both the NASA's plan for lunar exploration and development that was released in April and the report last week from the White House that you might have seen, what they both do really well is say that there is an inherent government role in advancing lunar development. Government is willing to invest. And I know from my own personal experience in the last 10 years I worked for NASA, engaging with other space agencies around the world, they feel that too. And so these NASA and White House documents lay out very well the rationale for these public investments. However, it's clear to me that there won't be an unlimited supply of money, and government investments need to be sustainable over time to make a difference. We can't have directions changing every time there's a presidential administration change. We have to have a good plan for investing in the right stuff and stick with it, right? So that's why we're kind of excited about this workshop today. We'd really love your feedback on what are those investment areas, those technology gaps, and why are they important, and tie them to the creation of the economic conditions which will encourage other sources of money beyond government money. I think that's what we're hoping to get out of the conversations today. So with that, I'm going to turn it over to Beth and ask her to summarize the plan for the breakout sessions. Welcome back to the main event, everybody. I hope you found the breakout sessions to be productive. I popped in on several of them and was really impressed by the depth of the conversation and the activeness of the participants. So really looking forward to seeing what comes out of this and helping to edit the report that will go forward based on this workshop. There's a couple of just points that I heard that really resonated with me that I felt made sense to bring up, and a couple of the groups touched on this. The idea that the future needs to be really profit driven, and government action cannot squash motivating factors like self-interest. So that tells me that a government industry partnership is really essential, and it needs to be more multidimensional than it is now. NASA likes to talk about this being a government industry partnership, and when they talk about that, they usually mean, therefore, we're going to use some creative ways to acquire capabilities that we need. Well, the government and industry ought to start talking now about more things in order to make sure we do this right, in order to make sure that we've given, all the possible business cases the opportunity to close. So for example, we need some people mentioned we need legal frameworks, and we do, but they can't have too many rules of engagement, right? That will cause some issues. So let's start a dialogue on that altogether. And there are areas that have come out of this discussion that might be ways you could make profit on the moon, from water ice tourism, helium-3. Let's start understanding today what factors create the best chance of these things being successful, and not to say that NASA needs to go all in and enabling them to be successful, or governments need to, but governments can do things along the way that give better chances for all these possible business cases to close. So again, start a broader government industry dialogue on the things that they ought to be partnering on over in the next years to realize our lunar settlement vision. And lastly, in several teams, I heard the issue of cost of access to space. Obviously, that was is a big barrier, and everything needs to be done to try to lower those costs. So that is something that we probably need to talk more about and do more about. So with that, I'll open up the floor and see if there's anybody, recognizing that we're at the end of time, anybody that feels like they'd like the floor for a couple of minutes before we conclude. Remember, all your reports will get in the hands of Jessica Todd, who will develop a draft report, and will circulate it to the bigger stakeholder community when it's finished. But anybody want to make any remarks?
I would, if it's okay.
Sure.
So we had a great group, and after I hit submit, I don't have the whole thing in front of us, but a couple of things that were mentioned by us were conservation of resources. So we all like to think that there's infinite water on the moon, but there may not be, or it might be much harder to get. So the ability of thinking about non-chemical propulsion So on the moon, low gravity, no atmosphere, easy to slingshot stuff off by mechanical means. And that is something that was talked about early on in our science fiction world, but has not been talked a lot about in recent times. But we do have the technology to do it. And then one other great comment that someone made is that when we talk about people wanting to go to the moon for long periods of time, in human history, oftentimes it's a small, almost sometimes fringe group of people who are very socially and economically strong and very unified in thought and process. And they are often the ones to make a jump to a new territory. And that could be a tribe of, from somewhere, anywhere in the world moving to a new location, or it could be, religious groups or any other types of groups. So we should keep that in mind, that it may not all be industry and commerce. There may be social movements at some point afoot. I think there were a number of other great ones, but those were the two of the stronger ones I recall.
Super. Well, those are great parting comments. So thank you very much for that. And thanks again to everybody who participated in the breakout sessions. We're really looking forward to seeing the compilation of your recommendations.